welcome back to another video. So today I'll be solving the AS level chemistry specimen paper of 9701, which is Cambridge. So this paper is completely based on the new syllabus, which will be followed from 2022. So let's solve it. So the first question says, which molecule contains 8 bonding electrons? A very important word to highlight is bonding. So we need to see which one contains 8 bonding electrons. So let's start off with carbon dioxide. So in carbon dioxide, we know a carbon is double bonded with oxygen. So each of these bond will contain 2 electrons. Over here we have 1, 2, 3, 4. So we have 4 bonds, each contain 2. So there are 8 electrons. So A is our answer. Now if you want to check what these things are, here we have got ethene, which is C double bonded with C, and there are 4 hydrogen. So over here we have got 2, 2, 4. So here we have 4, here 2, 2, 2, 2. So we have got another 4 plus 4, which gives us around 12 electrons. So this is wrong, so these ones will also be wrong. So that's our answer, A. So the second question says, beams of charged particles are deflected by an electric field. In identical conditions, the angle of deflection of particles is proportional to charge by mass ratio. Okay, so our deflection will be proportional to the charge by mass ratio, as they mentioned. So in an experiment, protons are deflected by an angle of 15 degrees. Okay, so protons have a charge of +1 and a mass of 1. In another experiment, under identical conditions, particle Y is deflected by an angle of -5 degrees. Okay, now it says what could be the composition of particle Y. So firstly, we need to identify and see that there is a negative sign which they have given. That means that this is deflected in the opposite direction. Okay, so this is one important thing, that it has been deflected in the opposite direction. This means that these has to have more electrons than protons, because we know electrons are oppositely charged. Okay, oppositely charged because electrons are negative and protons are positively charged. So whichever option has more number of electrons shall be it. More number of electrons is protons, which we can see only in option B. But let's clarify some more things here. So our answer choice will be B. So this is pretty clear. That is a very simple way to understand this question, that electrons shall be more because it is being deflected in the opposite direction, and protons are positive, electrons are negative. So these has to be the possible option, because other choices does not show this kind of thing. Okay, so question number 3. The mass spectrum of simple lithium shows that it contains 2 isotopes, these lithium-6 and lithium-7. The isotopic abundances are shown on the table. What is the relative atomic mass of a sample of lithium given to 3 significant figure? So whenever we are asked to calculate relative abundance, a very simple shortcut of doing this is just multiplying 6 times this thing and 7 times 92.58 divided by 100, because at first we can do this thing because we can add these two up and we're gonna get 100. So 7.42 plus 92.58, this will give us 100%. That means we do not have any other isotopes of lithium. Now we can just use this formula of 6 times 7.42% plus 7 times 92.58% divided by 100. If we do this calculation, it shall give us something like 6.9258. It says 3 significant figures, so it will be 6.93. Okay, which can be seen in option D. So D is our correct response here. Question number 4. Diamond, graphite and Buckminster fullerene are different forms of element carbon. So we know these are allotropes of carbon, which are different forms of the same element. Next, the question says, which statement is correct for all 3 substances? Okay, so we know that these 3 are the allotropes of carbon, and let's go through the options now. Bond angles of 120 degrees are present. Delocalized electrons are present. Delocalized electron is only present in graphite, but it's absent in diamond. So option B shall already be eliminated. Then option C says giant molecular crystalline structures are present. This is wrong because Buckminster fullerene, as we know, is actually a simple molecular structure. Okay, so option C is wrong. Option D says sigma bonds are present. This is always true because all of these shall have a sigma bond. Okay, because these carbons are always single bondedly present. Now option A says bond angles of 120 degrees are present. It shall not be 120 degrees, it shall be 109.5 degrees because we know these are all tetrahedral structure. So tetrahedral structure shall always have 109.5 degrees. Okay, so option A is also wrong. So only option D is correct. Question number 5. A metal has a total surface area of 150 cm cube. It is evenly coated with silver by electrolysis. Its mass is increased by 0.216 grams. How many atoms of silver are deposited per centimeter cube on the surface of the metal? Okay, so at first let's calculate the moles. So this is our surface area. So at first we need to calculate the moles of silver because its mass has increased by 0.216 grams. So this increase in mass is due to the presence of silver. Because of the silver coating, this mass has increased. So at first let's find the moles of silver. So moles of silver will be 0.216 divided by the mR of silver, which is 107.9, and this will give us 2 times 10 to the power minus 3 moles of silver. Okay, so this is the surface area which is these are the moles of silver that has coated, which has caused this increase in mass. Now let's calculate the atoms of silver. So number of atoms, because it says we have to calculate how many atoms. So number of atoms, as we know, is moles times Avogadro's constant, which is 6.02 times 10 to the power 23. So let's just do it. 62 times 10 minus 3 times 6 times 10 to the power minus 23, 6.02. Okay, let's write the full Avogadro's constant. So 6.02 times 10 to the power 23. Okay, so this will give us 1.2 times 10 to the power 21 molecules. Atoms. Okay, so now some people may jump to the answer immediately, but we have to look at another important thing which they've asked in the question, which is how many atoms of silver per centimeter cube. So these are the atoms of silver which has been coated in 150 cm cube, because we have calculated for 150 cm cube here. So we can just do unitary method, which is 150 cm cube contains 1.2 times 10 to the power 21 atoms. Therefore 1 cm cube shall contain 1.2 times 10 to the power 21 divided by 150. So if you do this in our calculator, let me do it. 1.2 times 10 to the power 21 divided by 150. This will give us 8 times 10 to the power 18 atoms. Okay, so the answer is A. Let's go to our next question. It says nitrogen has a higher first ionization energy than oxygen. Okay, which statement explains this observation? So let's go and see the number of electronic configuration of nitrogen and oxygen. So nitrogen is 7 and oxygen is 8. So it's 1s2, 2s2, 2p3, 2, 2, 3, 7. 1s2, 2s2, it is 2p4. So over here in 2p3 we know there are 3 orbitals and all of them are arranged singly, all the electrons, whereas for oxygen one of the electrons are in pairs. So this one, which you can see in 2p4, is in pair, whereas over here all of these are unpaired electrons. So this pair will cause spin pair repulsion, or which is basically the repulsion between electrons, because they're like charged, both of the electrons are negative. So this is due to the spin pair repulsion. So now let's go through our options and say which one actually gives us that. The radius of the oxygen atom is smaller. No, this is not a correct reason. That will mean that the ionization energy shall be higher in oxygen, which is not the case. Next option, it says oxygen atom has more electron shells occupied. This is wrong because they have the same number of shells because they are in the same period. Oxygen has a paired electrons in the 2p subshell. Yes, this is correct. As you can see in the 2p4 we have one paired electron which causes it to experience spin pair repulsion. So the option C is correct. And option D says oxygen has more protons in the nucleus. This will increase the nuclear attractive force, so this shouldn't actually be the reason why the first ionization energy of nitrogen will be higher. That would mean the oxygen shall be higher. Okay, so option D is also wrong because this does not explain why a nitrogen has a higher first ionization energy. Okay, question number 7, it says which molecule has the largest overall dipole moment? Okay, so we need to look for the largest. Over here we can see in option A all are carbon hydrogen bonds. So carbon hydrogen bonds, the electronegativity difference is very low, so these will be non-polar actually. So option A is automatically wrong. In option B we can see that these parts are actually non-polar. Over here we have an oxygen which is bonded to carbon. Now oxygen is more electronegative, so it will have a delta or partial negative charge, and carbon shall have a partial positive charge. This will cause a dipole moment to happen, and therefore there shall be a dipole moment will be experienced. So option B can be a possible choice. In option C we can see that these chlorines, there is a high difference in electronegativity, so these will also produce dipole moments. So this top, bottom and to the right, and this oxygen will also produce it. But we have to understand that this one and these dipole moments, since they're both from chlorine, they're going to cancel each other out, whereas this one from carbon oxygen and carbon chlorine, these dipole moments will also counteract each other, which will cause this dipole moment to be very low. Okay, and this will obviously be lower than this one because in option B is just oxygen which is causing it to experience a dipole moment toward the left, whereas over here this left is being counteracted by the chlorine, so this will cause the overall dipole moment to be reduced. So option B experiences more dipole moment. Okay, let's just also go to option D. So B shall be our answer here, but option D, over here we can see these parts will be almost non-polar, whereas these one have a dipole moment here to the right and top, over here to the left and the bottom. Now these top and the bottom will counteract each other, so these dipole moments will get cancelled, and the same goes for the left and the right. These two will counteract each other and cancel each other out. So only option B is a correct response here. Question number 8, a complete combustion of 2 moles of alkane produces 665 dm cube of carbon dioxide measured at 400 Kelvin and 1 times 10 to the power 5 Pascal pressure. Carbon dioxide can be assumed to behave as an ideal gas under these conditions. Which is the formula of this alkane? So let's just write our general equation for combustion over here. So our general equation for combustion would be CXHY plus x plus y by 4 oxygen will produce carbon dioxide x, and water will be y by 2 moles of water. Okay, so over here in a question it says that complete combustion of 2 moles of an alkane. So the alkane shall be 2 mole over here, will produce 665 dm cube of carbon dioxide. So 665 dm cube measured at 400 Kelvin temperature and 1 times 10 to the power 5 Pascal. Okay, so for carbon dioxide we can use the ideal gas equation, because there we have the question has mentioned that carbon dioxide can be assumed to behave as an ideal gas under these conditions. So let's use the ideal gas equation, which is PV equals to nRT. So pressure is 1 times 10 to the power 5, volume we have got 665, and to convert it to meter cube, so 10 to the power minus 3. Here we need to find the moles. R is equal to 8.31, and our temperature is given in Kelvin, which is 400. Over here if you find out the moles, you're going to see it's 20 moles. So over here x shall be 20. Okay. Now, however, one important thing in the question which you have to notice is that they mentioned the 2 moles of alkane. So this is actually 2 moles of this is reacting. So 2 moles is producing 20 moles of carbon dioxide. Therefore, 1 mole shall produce 10 moles of carbon dioxide. Therefore, our X shall be 10 here. Okay, so it shall be C10 somewhere, and since it is say that this is an alkane, so it shall be C10H22, because we know the general formula for alkane is CnH twice n plus 2. So it's 10, and 2 times 10 is 20, plus 2 is 22. So option C is our correct response, because they have mentioned that 2 moles of this reacts. They did not mention 1 mole. Okay, that's why we have to consider the 2 moles. So that's another trick which Cambridge played here. Okay, let's move on to question number 9. It says, which expression gives a standard enthalpy change of combustion of methane? Okay, now in the options they have all given a standard enthalpy change of formation. So everywhere they have given us formation, so we have to work with formation in this question basically. Now if we so at first let's write down the equation for the combustion of methane. So methane is CH4. So combustion is basically reacting with oxygen to form carbon dioxide and water. So 1 mole carbon, so 1 carbon, 2 hydrogen, so it shall be 2 over here. So over here we have got 2 oxygen and 2, that means 4 oxygen, so 2. Let's see if our equation is balanced or not. So 1 carbon on both sides, 4 hydrogen and 4 oxygen. So our equation is balanced. So let's see. So over here we have formation of carbon dioxide. We have got enthalpy change of formation of water given to us, and we also have enthalpy change of formation of methane given to us, and we have to find out enthalpy change of combustion. Okay, so this is our main equation which we have enthalpy change of combustion. So we know a very basic formula to apply to this kind of question which always works is enthalpy change of reaction, or basic reaction is enthalpy change of formation of the products minus enthalpy change of formation of the reactants. So whenever you see these kind of questions, if you directly apply this formula, you will directly get the answers. So enthalpy change of formation of products, so over here we have got products to be only carbon dioxide, so enthalpy change of formation of carbon dioxide minus we also have water, so enthalpy change of formation of water, but we have over here 2 moles of water, so we have to multiply by 2. Okay, because 2 moles of water is being formed, so 2 times enthalpy change of formation of water minus we have enthalpy change of reaction of reactants, which is methane, so del HF of CH4. So whichever options give us this equation will be our correct response. So let's take a look at the options right now. So option A says this thing, it gives it positive enthalpy change of formation of methane, so which is wrong. Formation of carbon dioxide plus 2 times formation of water, yes, but then again it gives us a plus sign which makes it wrong. The formation of methane, 2 moles formation of water, minus it gives carbon dioxide, it does not give a minus here, so this is wrong. And in D we can see that this exactly matches our equation here, so D is our correct response. Question number 10. Solutions containing chlorate 1 ions are used in household bleaches and disinfectants. These solutions decompose on heating as shown. Okay, they have given us an equation. So what are the oxidation states of chlorine in these 3 ions? So we have to find out the oxidation states, which is pretty simple and straightforward. So chlorine, we know oxidation state of oxygen is -2, which is equivalent to -1, which is basically the charge here. So over here chlorine is equal to -1 plus 2 will give us +1. So +1, so option B and D can be eliminated. Then ClO3 minus, so chlorine minus oxygen is -2, so -2 times 3 because there are 3 oxygen, -1, so chlorine -6 -1, so over here we can find that -1 plus 6 will give us +5. So Yep, it just gives option C. So just for clarification, let's also see over here they have already given us, so this is -1, this has to be -1, which gives option C to be a correct response in this question. Okay, question number 11. It says when KMnO4 is dissolved in water, the following reaction occurs. What could be the values of A and C in the balanced chemical equation? So over here, one important thing which you have to notice before we start proceeding with writing the whole balanced equation using the half equations is, do you have hydrogen or hydroxides in the question? Over here, one important thing is that they have given hydroxide in the question instead of hydrogen, which we typically see in some other past years, especially in 2020. Many questions of this kind actually popped up in the exam, but they had hydrogen or H plus instead of OH minus. So wherever we have OH minus, we need to balance the half equations using OH minus rather than using hydrogen, because if we use up hydrogen, we are not going to get any kind of hydrogen in the equation which they have provided us. So that will just lead to a wastage of our own time, and at the same time not finding the answer. So that's not what we want. So at first we have to take a good look at the equation and then start writing the half equations to see what shall be the value of A and C. So the first half equation which we can write down is of this manganate MnO4 2- to MnO4 minus. So let's write it down. So MnO4 2-, let's leave a gap for our balancing, will be converted to MnO4 minus. Okay, so let's start balancing it out. So over here we have got one manganese, one manganese actually. So it's manganese, one manganese, 4 oxygen, but however the charges are not balanced, so we need to add an electron over here to balance the charges. So that's basically it. So the first balance was pretty straightforward. Next, this MnO4 2- will now get converted to MnO2. So let's now do this. So MnO4 2- is getting converted to MnO2 solid. Okay, now we have to do some balancing, because here we can see that 4 oxygen here, 2 oxygen here, so we need to get 2 more oxygen, so we can just add 2 hydroxides. So that will mean that there's 2 more oxygen, so oxygen is balanced. But however, this leads to another problem. That means there are 2 hydrogen, there's no hydrogen here, so we need to also add hydrogen. So to add hydrogen in these equations, we can just add water. Okay, so we can just add water over here, but that leads to another problem. That means that the oxygen is now no longer balanced. Okay, so now in order to balance the oxygen atoms, we can do one thing, that is we can just now do, oh my gosh, what happened? Okay, we can just make 2 moles of water, and we can just make 4 moles of hydroxide. So that means 4 plus 2 6 oxygen, 2 plus 4 6 oxygen, and 4 hydrogen. It's better not to change this manganese thing, because that would lead to more balancing and that will make it more complicated. So now we need to balance out the electrons. So over here we have -2 charge, here we have -4 charge, so we need to balance the charges. So -2, so -2 we'll get -4 charge on the left hand side. So let's write it on the top, because it makes it easier to understand. So yeah, so over here we have equal charges on both sides, -4, both on the right hand side and left hand side. Now let's multiply 2 with the top equation, so that will give us 2 on all this, because we need to cancel out the electrons. So now if we write the overall equation for this, these 2 electrons and 2 electrons, we cancel each other out. We have 2 MnO4 2- plus on the left hand side we have MnO4 2-, so this basically adds up to get 3 MnO4 2-. So let's write it all together. So 3 MnO4 2-, we have got 2 moles of water over here, and over here we have got 2 moles of MnO4- plus MnO2 plus 4 moles of hydroxide. Okay, now we can finally see what A and C are. So A is over here, so this 3 will be our A, so option B, and C has 3. and our C is this thing, MnO4 minus, before MnO4 minus, so our C will be 2. So C is 2, A is 3, so our answer is C. Let's move on to our next question. Okay, it says methanol can be produced from hydrogen and carbon monoxide. What is the Kp for this reaction? This is very simple. So Kp, we know this is the partial pressure of products, which is CH3OH divided by partial pressure of reactants raised to the power of whatever is before them, and carbon monoxide, partial pressure of carbon monoxide. So that's basically our equation. So let's see where we have it. So this is only available in option C. So C is our correct response. Okay, question number 13. 4 grams of powdered calcium of Mr 100 is added to 100 cm cube of 0.1 mole per dm cube hydrochloric acid. The volume of carbon dioxide produced is recorded every 30 seconds. Okay, which row of the table is correct? So as you can see, as the time is increasing, we can see the total volume of carbon dioxide. So let's just compare between the two. So over here we have a difference of 30, 18. Over here we have 13, 9. This is basically the difference between this one and this one. So 88 minus 70 is 18, 101 minus 88 is 13, 110 minus 101 is 9, 116 minus 110 is 6, this is 4, and this is basically 0. So we can just see that the rate of increase in volume is slowly decreasing of carbon dioxide which is being produced. So it has to be fewer collisions between the reacting molecules. Okay, because the more number of collisions, so the volume of carbon dioxide, the rate of reaction should have increased. But over here we can see that the rate of reaction is decreasing because the time interval is always the same. The time interval is always 30 seconds. Okay, so the time interval del t is always 30 seconds, but however we can see that the amount produced within this 30 seconds is slowly decreasing. So this has to be fewer collisions. Now why the reaction stop? It says the calcium carbonate is being used up, the hydrochloric acid is being used up. So for this we need to construct an equation for this reaction. So let's just do it. So calcium carbonate reacts with HCl to form calcium chloride plus carbon dioxide plus water. So this is a basic equation. So to balance it, this has to be 2 moles of HCl because 2 chlorines are produced. So that's our equation over here. So now let's calculate the moles. So it says 4 gram of calcium carbonate of Mr 100. So they have also given us Mr. So moles of calcium carbonate shall be 4 divided by 100, which gives us around 0.04 moles of calcium carbonate. For hydrochloric acid, they have given us the volume, so volume and concentration. So we can just calculate the moles from here. So if we do it, then we're gonna get 0.1 moles, I believe. Let's calculate 1 by 1000. Sorry, 0.01 moles. Okay, so 0.01 moles. So over here we can see that 0.01 moles would actually require so over here it says 0.01 moles, which is actually lower number of moles than calcium carbonate. So this is our limiting reagent. Okay, because calcium carbonate is in excess. For 0.01 moles we need 0.01 divided by 2, which is around 0.005 moles of calcium carbonate is required for this 0.01 moles of HCl. But over here we have excess of calcium carbonate, so that is obviously our excess reagent. So because this reaction stops, this reaction will stop due to the limiting reagent. Okay, so due to the limiting reagent. So over here in this reaction our limiting reagent is hydrochloric acid, so our answer is B. Question number 14. Which statement about ideal gases is correct? Okay, so ideal gases have a finite particle volume and no intermolecular forces of attraction. No, it doesn't have a finite particle volume. it shall have a zero particle volume, because you need to understand that the volume of one gas compared to the volume of whole gas shall be negligible. Okay, negligible compared to whole volume. Okay, so ideal gases should not be having a finite volume, so option A and B are wrong. But it is true that they have no intermolecular forces. This option is true because we assume that there is no forces of attraction between them, so they so that's a consideration which you do for ideal gas equation. So in option C it says it has zero particle volume, which is true, and no intermolecular forces of attraction, which is also true, so option C is our correct response. Question number 15. A mixture of gases consists of 12 grams of hydrogen, 42 grams of nitrogen, and 4 grams of helium. What is the mole fraction of hydrogen in this mixture? Okay, so let's just do it. So hydrogen, nitrogen, and helium. So these are what we have. So we have 12 grams of hydrogen, 42 grams of nitrogen, 4 grams of helium. So if we divide them by their respective MRs, we are going to get, sorry, it's actually 4. So over here we have 6, 1.5, and 1. So over here, if we have to calculate the molar fraction of hydrogen, it shall be 6 divided by 6 plus 1.5 plus 1. So if you do this math in a calculator, 6 divided by 6 plus 1.1 plus 1, that's going to give us 0.71 to 2 dp. So the answer to this question is C. Okay, next question number 16. It says, what is the definition of bond energy in BR-BR covalent bond? So we know bond energy is basically the energy which is required to break 1 mole of any kind of covalent bond in gaseous state. So between BR-BR covalent bond, so it shall be the energy required to break the BR-BR bonds in gaseous state. So let's go to the options. So the energy required to produce, no, not producing, bromine atoms. This is completely wrong. Option B, it says the energy required to produce 1 mole of bromine atoms in liquid state. No, we have to get gaseous state. So which gives us option C as a correct response. The energy required to break 1 mole of BR-BR bonds in gaseous state. That's correct. Option D says liquid state, so that's wrong. Question number 17. It says which graph shows the relative melting points of elements magnesium, aluminium, silicon, phosphorus plotted against the relative electronegativities. So over here we know that silicon will have the highest boiling point because this is a giant molecular structure. Okay, so silicon will have the highest, followed by aluminium, then magnesium, and finally this will be phosphorus because this is a simple molecular. This magnesium aluminium has metallic bond which is very strong. Aluminium has more number of electrons in the valence shell, so aluminium will have a higher melting point than magnesium. So let's first compare the melting points. The melting point, as you can see, option B, silicon stays at top, the aluminium, magnesium, phosphorus. So this gives us a proper melting point chart. Whereas in option A, this is wrong because it shows aluminium. Option D is also wrong because that also shows aluminium. Option C, it shows silicon and then aluminium, magnesium, phosphorus. Okay, that also makes sense only in terms of melting point. Now we have to observe the other thing, which is relative electronegativity. So let's just compare the electronegativities of option B and C to decide our final option. So option B, as we know, for the electronegativity trend, as we move from magnesium to phosphorus, the electronegativity shall increase. Okay, why the electronegativity shall increase? Because we know from magnesium to phosphorus the atomic radius decreases, and also the nuclear charge also increases, so which causes the atomic radius to decrease, and the shielding effect remains constant. So as a result, the electronegativity across a period always shall increase. Okay, so this is also only shown by option B, so option B is correct. Option C does not show it. It shows that phosphorus has a lowest electronegativity value, which is absolutely wrong. Next, let's go to question number 18. An excess of magnesium oxide is shaken with water. The resulting mixture is then filtered. The filtrate W. 2 drops of dilute sulfuric acid is added and any observation is noted. When an excess barium oxide is shaken with water, the resulting mixture is filtered. This is filtrate X. 2 drops of dilute sulfuric acid is added and any observation is noted. Which row is correct? So magnesium oxide, when it is shaken with water, will form magnesium hydroxide. Okay, now next we have taken 2 drops of dilute sulfuric acid added. So now we are going to add dilute sulfuric acid to it, which will form magnesium sulfate plus water. Okay, next is a barium oxide is now shaken with water. The mixture, the resulting mixture is filtered. This is filtrate W. Okay, so this, as we know, is solid, a white precipitate. So this will be our W. Okay, so magnesium hydroxide is a W, so let's highlight it. So this is filtered, and magnesium hydroxide, we are going to add sulfuric acid to only magnesium hydroxide, which will produce magnesium sulfate and water. Next, it says an excess of barium oxide is shaken with water. The resulting mixture is filtered. So now barium oxide, when it reacts with water, it will form barium hydroxide. So this is our filtrate X. So this will be our X. The 2 drops of sulfuric acid is added and any observation is noted. So H2SO4, when it is added, you are going to get barium sulfate. Okay, so now we know barium sulfate is solid, so this will form a precipitate. Okay, now it says filtrate with the higher pH. So we already know filtrate X shall have the higher pH because barium hydroxide, as we go down group 2, as we go down the group, the pH value, the pH nature increases because they are more basic. So basic property shall increase, so obviously X shall have the higher pH. So that's for the first choice. Then it says observation in addition to sulfuric acid to the filtrate with higher pH. So that means sulfuric acid, that means barium sulfate is produced, which is, as we know, is a solid, so it shall be a white precipitate, which gives us option D. Because as we know, group 2, as we go down the group, sulfates reactivity decreases. Okay, that means the sulfates become solid because a solid layer of sulfates is formed as you go down group 2.